Hey, what's up everybody? We're gonna do some quick practice here to get a little bit better understanding about the relationship that exists between hydronium ion concentration, hydroxide ion concentration, and then both pH and OH. So the very first thing that we're gonna do is look at whether or not the following will be acidic, basic, or neutral. Now, before we answer these questions, a couple of things just to keep in mind. One, remember the relationship that exists between hydronium ion concentrations and hydroxide ion concentrations that is given to you on your formula chart. Remember that at 25 degrees Celsius, the value of Kw is equal to 1.0 times 10 to the negative 14. Okay, the first 5 questions are giving us concentrations of either hydronium ions or hydroxide ions, so I'm going to look at this relationship that exists in the Kw expression. In question number 1, we're given a hydronium ion concentration of 1.00 times 10 to the negative 4. We know that Kw has to stay constant at 1.0 times 10 to the negative 14, which if I solve for x would give me a hydroxide ion concentration of 1 times 10 to the negative 10. So ultimately, all you have to ask yourself is, okay, Kw in pure water, the concentrations of hydronium and hydroxide are each going to be 1 times 10 to the negative 7. And then recognize as the hydronium ion concentration increases, your hydroxide ion concentration will decrease, and that's characteristic of acidic solutions. And conversely, recognize that as your hydroxide ion concentration increases, your hydronium ion concentration must decrease, which is indicative of basic solutions. So as I look at the concentration of hydronium ion provided to me in question number 1, I recognize that that is an increase from the 1 times 10 to the negative 7 of pure water, which means that hydroxide ion must decrease, in fact, to 1 times 10 to the negative 10, which means that this solution is indicative of an acidic solution. The concentration of hydronium ion will be greater than the concentration of hydroxide ion. As I look at number 2, here the hydronium ion concentration is 1.00 times 10 to the negative 10. Again, keep in mind that Kw is a constant, which means that it is going to be 1.0 times 10 to the negative 14. If you solve for hydroxide ion concentration, recognize that here we have a decrease in the hydronium ion concentration from that original neutral 1 times 10 to the negative 7 that we saw in pure water. And therefore, if hydronium ion concentrations decrease, hydroxide ion must increase. In fact, it will increase to a concentration of 1 times 10 to the negative 4. And when hydroxide ion concentrations are greater than hydronium ion concentrations, we have a basic solution. Now, the next couple we're going to try without writing anything out, but again, come back to this idea of Kw relating the concentrations of hydronium ions and hydroxide ions. Hydroxide ion concentration of 1.0 times 10 to the negative 7. Well, if hydroxide ion concentration is 1.0 times 10 to the negative 7, and Kw is a constant, what must hydronium ion concentration be? It must also be 1 times 10 to the negative 7. Therefore, this is indicative of a neutral solution. Okay, as we look at number 4, it says we have a hydroxide ion concentration of 1.00 times 10 to the negative 11. Again, Kw must remain constant. So in order for our hydroxide ion to decrease to 1 times 10 to the negative 11, our hydronium ion concentration must have increased, in this case, to 1 times 10 to the negative 3. So in this situation, we would have an acidic solution. As we look at question number 5, here we're not given an actual numerical value, we're just told that these two concentrations are the same. Well, again, Kw has to remain constant, 1.0 times 10 to the negative 14. Again, we aren't given specific numerical values, but they must be the same number. In this case, they must each be, I'll say, x. And so if we solve this, 1.0 times 10 to the negative 14 is equal to x squared. If you take the square root of each side, you're going to end up with 1 times 10 to the negative 7. And so when you have equal concentrations of hydronium ion and hydroxide ion, you will have a neutral solution. Okay, and for questions 5 through 9, we're asked to think about the relationship between pH and pOH and what that means in terms of acidic, basic, or neutral solutions. And again, the relationship that exists between pH and pOH is the following. In other words, the sum of the pH and pOH must equal 14. And again, that comes back to the understanding of the relationship between hydronium ion and hydroxide ion concentration as described in the Kw expression. So as we take a look at question number 6, the pH is 3. Again, because 14 has got to be a constant, the pOH has got to be 11. And a pH of 3 and a pOH of 11 indicate that this is an acidic solution. As we take a look at question number 7, pH is 13. Again, the sum of the pH and pOH values must equal 14. In this case, the pOH would be 1. A pH value of 13 and a pOH value of 1 is going to be indicative of a basic solution. Let's take a look at question number 8. pOH is 9. Again, that sum of pH plus pOH must equal 14. In this case, we get a pH value equal to 5. A pH of 5 and a pOH of 9 is going to be an acidic solution. As we look at question 9, now we're given pOH of 5. Again, the sum of pH plus pOH is going to equal 14. So we get a pH value of 9. So in this case, we'll end up with a basic solution. So ultimately, your goal is to think about the relationship between the hydronium ion concentration, hydroxide ion concentration, relate these to pH and pOH scales, and recognize the relationship that exists between them. As one of the concentrations increases, what happens to the other concentration respectively. And then what does that mean in terms of either the pH or pOH values?